this. So number 7 on the practice sheet. Our given is 450 grams of sodium. We have grams of sodium down here to cancel. We have moles of sodium up here to end up in. 1 mole, 22.99 grams. What's your raw answer? Yeah, 57372771 moles of sodium. Okay. How many sig figs can you have? 4. 450.0 is 4 sig figs. So we're going to go there, and we have 19.57 moles of sodium. Okay, and number 9, how many moles? So this was grams to moles. Grams to moles. And let's look at a moles. I'm sorry, that was mole. Yeah, that was grams to moles. Let's look at a moles to grams. So number 11 is, okay. Yes. Okay, so our given here is 5.75 moles of manganese, not magnesium, be careful. And we know that we want moles of manganese here to cancel, grams of manganese there to end up in, so our units and chemical cancel. How many grams of manganese in 1 mole? Yep, 54.94 grams in 1 mole. And what's your raw answer? Oops. Units, grams of manganese, and how many sig figs can we have? 3, because of that given. So we're going to end up with 316 grams of manganese, not MW, there, as our final answer. Let me put this on here. Okay, I don't know, I'm going to have to take keys in at night or something, I don't know. I'm really rather distressed by this. 1 mole manganese, 54.94. Do what? Well, I've always put them out in the hall so that, like, if I'm teaching a different class, students can stop by, like, during their study hall or whatever. So, and I've never had this problem before. I have never, ever had a key disappear off the wall. So I didn't expect this to happen, because it's never, I've been doing this for years. It's never happened. Yeah, I mean, obviously, every year's different. It's all a different mix. So, you know, I may have an ornery sophomore who's got a locker nearby who thinks this is hilarious. Just wait till I electrify the whole wall. So don't lean up against it next time you check those keys. We have stuff in physics. We have stuff. Okay, 315.905 grams of manganese, 316 grams of manganese. Okay, which other ones do you want quick answers for? We had done, what, 7, 9, and 16. Okay. Oh, that's right, because we had the little reversal, who found my mistake on 9. So we have 72.6 grams of boron, and we want to know how many moles of boron that is. We have grams of boron, moles of boron. 1 mole of boron is 10.81 grams. Grams of boron cancels, and we end up with 72.6 divided by 10.81, 6.716037 moles of boron. Yeah? Sig figs, how many? 3. So 6.72 moles of boron. How are you doing so far? Okay, wunderbar. So you've got one concept down. You know what that means? It's time to add a new one. Always keeping in mind your GMA. So we've gone gram to mole, we've gone mole to gram. Let's talk about atoms, shall we? How many atoms of anything are in 1 mole of that thing? 6.022 times 10 to the 23rd, yeah. If you want to get that number tattooed on your inner arm, that's fine. You can still use your arms during tests. 6.022 times 10 to the 23rd atoms in a mole of anything. What that means is if we know how many moles we've got, we can figure out how many atoms we have. So far the conversion factors that we have used, because we've done gram to mole, mole to gram. So far we've been doing, mass over moles or moles over mass as we go from grams to moles or vice versa. Well, now we're going to go from atoms to moles and moles to atoms. So the conversion factor that we're going to use is number of atoms per mole or moles per number of atoms. Let's just get rid of this. So suddenly these are the conversion factors we're using. This number of atoms is the same for every single element. It never, ever changes. And it is always what? 022 times 10 to the 23rd. Yeah. Like a little army of chemistry drones. 6.022 times 10 to the 23rd. Yeah, it's never going to be different. You're never going to have any other number next to the word atoms. Write that down someplace. Seriously. You'd be amazed. People will put the molar mass next to number of atoms. No! They'll put 1 next to atoms. No! The only thing that's ever going to go next to the word atoms or molecules or anything like that is that number. 6.022 times 10 to the 23rd. Avogadro's number. That's the only thing you're ever going to write there. Okay. So, let's do some conversion. How many moles of calcium are in 2.01 times 10 to the 15th moles of calcium? So, our given is the number of, did I say moles twice? Okay. Our given is a number of atoms. So, that's what we put in our first box. 2.01 times 10 to the 15th atoms of calcium. What units in chemical do we need down on a diagonal to cancel? Atoms of calcium. We want to end up in moles, so those go in our final box up top. Moles of calcium. There will never be anything but a 1 with moles as a conversion factor. You'll never have some other number there unless moles is a given. What number goes here? 6.022 times 10. You can all mutter it like little chem zombies. 6.022 times 10 to the 23rd. Maybe we should do a chem zombie themed something or other. I don't know what. Zombies seem to be real popular these days. Okay. That's your setup. Atoms of calcium cancel out. Moles of calcium are what you're left with. Now let's do the math. Remember when I said soon we would be doing a lot more stuff with scientific notation? So this is 2.01 divided by 6.022 times 10 to the 15 minus 23. It's kind of a booger. Okay, there's our raw answer, and this is moles of calcium. We have to do 2 things to this number. We have to sig fig it, and we have to put it into correct scientific notation. If we kind of visualize that to make it a full number, we would be going this direction to the negative 7th, 6th, 5th, 4th, etc. Pretty soon, even my little puny brain figures out that this is to the negative 9th. So we know we've got 3 point something times 10 to the negative ninth. How many sig figs can we have? 3. So we're keeping this, and based on the number after it, that's going to round. So this is 3.34 times 10 to the negative ninth moles of calcium. Oh, hey, I forgot I had the answer there. Whoops. Okay, that's convenient. Not too hard. Let's do another one together. We're going to start off with our given, always in that first box, 1.16 times 10 to the 27th atoms of carbon. So what units and what chemical down here to cancel? Atoms of carbon. What units and what chemical up top to go into? Moles of carbon. Okay, what number goes with moles of carbon, Justin? One, yeah. What number goes with atoms of carbon, Morgan? Be careful. Next to atoms, we only ever have what number? 6. This is the one that you'll be getting tattooed on your arm as soon as you find a good tattoo artist. 6.022 times 10 to the 23rd. That is the mistake that people make. That's the right mistake to start the conversation, because that's why I stress that the only thing you ever write next to the word atoms or molecules is this number. Because you want to go, oh, it's carbon, 12.01. But then you're saying that there are only 12.01 atoms in 1 mole, and that's wrong. And it'll get you crazy numbers. Okay, so we have 1.16 divided by 6.022 times 10 to the 27 minus 22. Yeah, error check on Moser. That should be 23. Thank you. So you gotta keep on your toes. 3 sig figs, so we're gonna keep that number and round it based on the next number. So we have 1.93 times 10 to the 3rd moles of carbon. Okay. Pretty easy? Not too terrible? See if I can. Somehow I neglected a slide on this. So let's do one that's moles to atoms. So if I hand you, this is really actually kind of fascinating. If I hand you a chunk of carbon, so you've all seen pure carbon. If you get soot on something and you scrape it off, that black powder, you're basically looking at pure carbon. If I hand you a pile and I tell you this is 5.5 moles of carbon, can you tell me how many individual atoms you have in your hand? Yeah. Why, yes, you can. So let's do that very problem. 5.5 moles of carbon, and I want to know how many atoms of carbon I've got. So we start off with 5.5 moles of carbon. What units in chemical go down below to cancel? Jason? Moles of carbon. What units and what chemical go up top to end up in, Emma? What units in chemical? Atoms of carbon. You're right. You're just a step ahead. Okay, now, what number goes with the moles of carbon? Brianna? 1. Atom. What number goes with the atoms of carbon? 6.022 times 10 to the 23rd. Good. Okay, so now it's just a little bit of math. We have 5.5 times 6.022, the whole mess, times 10 to the 23rd. Okay, so we've got our raw answer here. How many sig figs can we have? 2. So we're only keeping this, so 3.3 times 10 to the what? 24th. Okay, and what are our units here? Atoms of carbon. This seems ridiculous, the idea of counting atoms, The place that this comes up is actually in physics, not in chemistry. This is, once we get through you learning how to do this, you don't do a whole lot more counting atoms because there's limited usefulness in what we do. However, in electrical engineering, you can take a segment of wire, and you know that different sizes of copper wire can carry different amounts of electricity, right? Why is that? It's because there are different numbers of atoms inside that piece of wire, and each atom can transfer one electron at some known rate. And so if you take a physics course in college that's whatever the sequence is where you're doing the electrical and magnetic stuff, you actually look at segments of wire and figuring out how many electrons can be transferred through a given piece of wire per second based on this exact kind of math, knowing how many atoms are in a section because of its mass. So this actually does have application. We don't do the application in here, but you do end up applying it if you go into electrical engineering. So we've got some section of wire, we've figured out its mass, and we figured out that we've got 1.22 moles of copper. How many atoms of copper do we have? So what units in chemical go down on the bottom to cancel? Tarek. Of? Thank you. And Katie, what units in chemical go up top? Atoms of copper. And Alexis, what number goes with moles of copper? 1. And Robbie, what number goes with atoms of copper? You got it. 6.022 times 10 to the 23rd. Okay, now it's just math. Okay, we've got a raw number. How many sig figs can we have, Alicia? How many? 3, right. So we're going to keep this number and round it based on that. So what is our rounded value, Tyler? 7.35 times 10 to the 23rd atoms of copper. Okay, pretty easy, yes? So now you know how to go from grams to moles, moles to grams, moles to atoms, atoms to moles. Guess what's coming next? Yep, two-steppers. So here's the thing. We're starting all these problems where I tell you, you have 12.2 moles of whatever. Exactly what in this lab are we using to measure the moles? Did you guys see the mole balances in the brown cupboard? The special ones? There are no mole balances. You can't directly measure the number of moles of anything. It can't be done. Because moles, our knowledge of how many moles of something we have comes out of its mass. We can't directly measure moles. So really those moles to atoms, moles to grams, yeah, okay, fine. They're useful in that you learn the skill and you learn the setup. In the real world, they're of limited use because we don't have a mole balance. We can't figure out how many moles something is without having a mass. So these two-steppers are really the ones that are the more common and more useful. But you learn the one-steppers as a means of sort of building up to them. So let's do a two-stepper, oh boy. So we're back to calcium. We keep using calcium all the time. And we're told that we have 2.01 times 10 to the 15th atoms of calcium. So that's our given. That's going to go in our first box, 2.01 times 10 to the 15th atoms of calcium. We want to know what the mass in grams is. Looking at this, can we go directly from atoms to grams? No, we can't. We have to go through moles, and that's why GMA is important, because it reminds you of that. It reminds you that you can't go straight from grams to atoms or atoms to grams. You got to go through the mole. So if we're going to go through moles, what units and what chemical go down here to cancel? Who have I not picked on yet? Andrew. I've been hiding in plain sight. Units and chemical. Yep. atoms of calcium. Okay, we have to go through the moles, so we're going to convert into moles. Alex, what units in chemical up top? Moles of calcium. Okay, because we have a relationship between number of atoms and number of moles. Well, now we're ready to go into grams, to go into mass. So what units in chemical are going to go down on the bottom in that last space to cancel? Who have I not? Steph, I haven't picked on you. Moles of calcium. What units in chemical? Hannah. No, I already picked on Alicia. Are going to go up top. Grams of calcium. Okay? You notice that you can look at it right now and know that all of your units are going to cancel out and you're going to end up in grams of calcium. And right there, you know that your setup is correct. Now the tricky part is making sure all the numbers you put in those places are correct. Okay? So, what number always goes next to moles as a conversion factor? Hold up fingers. 1! And never anything but 1. So that's got a 1. What number always goes next to atoms as a conversion factor? Yeah, hold up all your fingers. All of them. And your toes. And your hair. Yeah, 6.022 times 10 to the 23rd. Okay. That never changes. Now for our last box, what number always goes next to moles as a conversion factor? 1. What goes next to grams? Molar mass. To the periodic table. To the bat cave. 40.08. Oh yeah, it's right there, isn't it? Duh. Okay. So, let's copy this over and do the math. Okay, you've got a setup that looks something like this, I presume. You've taken all of these and you're multiplying them all. Okay, we've got a raw number. We have to do two things. We have to get it into correct scientific notation, and we have to sig fig it. So correct scientific notation would make it 1.3 times 10 to the negative 7th. 1.3 times 10 to the negative 7th. Yeah, okay. So, how many sig figs can we have? 3. And we're basing that on our given only. So we're keeping this and rounding based on that. So we have 1.3 what? 4. And we said it's times 10 to the negative 7th. What are our units? Grams of calcium. It's a tiny little amount of grams. When you're going from grams to atoms or atoms to grams, you got to go through moles. There's no way around it. Okay? Do you want to do one from grams to atoms, and then I'll turn you loose to work on your practice, or do you want to just turn loose to work on practice? Okay, we'll do a show of hands because I can't process sound that fast. Who here would like to do one more together? Okay, that's enough. Okay, if I hand you a 50-gram chunk of aluminum, you could easily take you could take aluminum foil and ball it all up and get a 50-gram sample of aluminum. How many atoms of aluminum do you have in your hand? This is just kind of like the mystic, like, whoa factor. So, what units and what chemical go down below to cancel, Tyler? Grams of aluminum. Okay, Brianna, what units and chemical are going to go above them? Moles, because we have to go through moles. Okay, what units and chemical go down below to cancel? Steph. Moles of aluminum. What units and chemical go up top to convert into? Jeremiah, are you with us, or are you working on your own? Okay, then you're fine. Morgan. Oh, sorry. Atoms of aluminum. Okay. All right, Justin. Can you give me the numbers for both? Here's where it gets tricky. Because when you're filling this in, you're not just focusing on one number, you're putting all those numbers in. So, Justin, can you give me the numbers for that middle block, top and bottom? What goes where? One mole. Remember that moles always gets a 1 next to it as a conversion factor. That's exactly why I asked it that way. So where do you get the number for grams? periodic table. Molar mass. And aluminum is... Okay. Alright. For that last box, who wants to give me the numbers for both top and bottom? Alicia. Yep. You got it. Okay, so now do the math. We've got our raw number. How many sig figs can we have? 3. So we need to put that, both put it into correct scientific notation and fix our sig figs. So correct scientific notation is going to give us, well, our sig figs, we're going to keep this and round based on that. So we're going to have 1.12, and that's times 10 to the 24th. Atoms of aluminum. Okay. The trickiest part is getting the right numbers where they go.